Welcome to today's explainer. We're jumping right into something that literally surrounds us, flows through us, and powers absolutely everything we do, even though it's completely invisible. We're talking about the fundamental mechanics of energy. Whether you're flipping on a light switch, grabbing a quick sandwich, or just sitting there listening to me right now, energy is actively at play. So, my goal for today is to give you a really crisp, structured breakdown of how energy actually works, so you can start spotting these invisible forces in your day to day life.
To kick things off, let me ask you something. Picture a massive roller coaster. You've got thousands of pounds of steel and passengers slowly climbing high into the air, plummeting down steep drops, and whipping through these crazy loops at incredible speeds. But here's the wild part. The roller coaster cars themselves don't actually have engines. So what exactly is the invisible force powering that massive thrill ride? How on earth does it keep moving with such intense force? Well, the answer lies entirely in how energy is stored, released, and transferred.
So, here is our roadmap for today. Number 1, the definition of energy. 2, potential versus kinetic energy. 3, 5 forms of energy. 4, energy transformations in action. And finally, number 5, the law of conservation. Let's get into it. Starting with section 1, the definition of energy. Now, energy isn't a physical object. You can't just put it in a box and hold it. Instead, it's defined as the ability to do work or cause change. It's basically the vital capacity to make things happen in our physical world, whether that's moving an object, heating up a cold room, or lighting up a dark space. If a change is occurring anywhere, energy is the agent causing that work to be done. Actually, just sitting still right now, simply processing what I'm saying, your brain is using about 20 watts of energy. To put that in perspective, that's enough to power a dim LED bulb. Moving right along to section 2, potential versus kinetic energy. In the physical world, energy generally hangs out in one of two primary states. On one side, we have potential energy. This is your stored energy. It's energy that's just waiting patiently to be used. Think of it as pent-up capacity. Then, on the other side, we have kinetic energy. This is the energy of active motion. Simply put, if something is moving, it has kinetic energy. And the golden rule here is pretty straightforward. The faster an object moves, the more kinetic energy it has. Think about a kid paused right at the top of a steep hill. Right at that moment, they hold massive potential energy. It's all stored up, just waiting for gravity to take over. You see the same thing with a rubber band pulled back super tight, or millions of gallons of water held behind a massive dam, or even just a heavy book sitting precariously on a top shelf. But the exact second that kid pushes off and starts rolling down the hill, boom, that stored potential energy becomes active kinetic energy. A rolling ball, wind blowing through the trees, a sprinter running down a track, all of these are just pure kinetic energy in motion. All right, section 3, 5 forms of energy. First up, we've got gravitational energy. This is a type of potential energy that's heavily tied to an object's physical position. It really depends on 3 specific things: the height of the object, the mass of the object, and the Earth's gravitational pull. Remember that roller coaster sitting at the peak of the track? It relies entirely on this position-based power. Same goes for falling objects or rushing waterfalls. The higher and heavier an object is, the more gravitational energy it has stored up. Next, we have electrical energy, which comes directly from moving electric charges. Honestly, this form kind of dictates our modern lives, right? It surges out of power plants and gets stored in batteries to run almost every single device you own. And out in nature, it puts on a pretty dramatic show as lightning. Just one single bolt contains up to 1 billion joules of energy, which, fun fact, is enough to toast 100,000 slices of bread in a fraction of a second. Our third form is chemical energy. Think about a leaf going through photosynthesis, turning sunlight, water, and carbon dioxide into carbohydrates. Chemical energy is basically a form of potential energy stored directly inside the chemical bonds of atoms and molecules. And we literally use this every single day. Every bite of food you eat contains stored chemical energy that your body breaks down to fuel your day. The gas in a car, the stuff inside a battery, even the head of an unlit match, they're all just packed with chemical energy, waiting to be released. Number 4 is thermal energy, which we usually just call heat. Now, thermal energy is actually produced by the kinetic movement of microscopic particles inside an object. When those tiny molecules bounce around really fast, you get higher heat. When they slow down and get less active, you get less thermal energy. You feel this form of energy all the time, whether it's the warmth of sunlight, a crackling fire, a hot cup of coffee, or honestly, just the radiant body heat you're giving off right now. Finally, our 5th form is light energy. Now, unlike the others, light energy is unique because it travels in waves. This is exactly how energy from the sun manages to cross the vast empty vacuum of space to reach us here on Earth. We capture and use this wave-based energy all the time. From the sun, sure, but also from light bulbs, candles, and the glowing screens you're probably looking at right now. But here's the really important part. These forms of energy don't just sit there in isolation. They are incredibly dynamic. Which perfectly cues up Section 4, Energy Transformations in Action. To really map out how energy continuously morphs from one state to another, let's look at something super common, a simple flashlight. In step 1, we start with the batteries, which are packed with stored chemical energy. When you flip that switch, we move to step 2. That chemical energy transforms into electrical energy, which quickly travels through the wires. By step 3, that electricity hits the bulb and transforms yet again, this time into light energy so you can see in the dark. But it doesn't even stop there. In step 4, if you leave that flashlight on long enough, you'll notice the bulb gets hot. That means the light energy is also transforming into thermal energy. One simple everyday device, but 4 distinct energy transformations. And you see these real-world transformations everywhere you look. A solar panel takes light energy from the sun and actively converts it right into electrical energy for our homes. I challenge you to try and spot other transformations around you today. Like, think about those massive windmills out in a field. They're transforming the kinetic energy of the blowing winds into electricity. Or what about giant hydroelectric dams? They use the potential gravitational energy of falling water to spin massive turbines and generate insane amounts of power. Energy is constantly shapeshifting. And that brings us to our final stop, Section 5, the Law of Conservation. Energy is never created or destroyed. That right there is the law of conservation of energy. And wow, it carries some serious weight. What it means is that all the energy currently existing in the entire universe is all the energy that will ever exist, period. We can't magically summon new energy out of thin air, and we definitely can't erase energy out of existence. We're really just borrowing it. It only ever changes forms. And Newton's cradle is the perfect way to visualize this concept. You know, the toy. When you pull back one metal sphere and let it go, it strikes the others. But the energy doesn't just disappear when it hits the stationary balls. Instead, that energy transfers flawlessly right through the middle, only to push the final ball outward. While the energy is constantly transferring and shifting forms from potential to kinetic, the total amount of energy inside that little system remains perfectly, mathematically, constant. Let's tie all of this together with a baseball pitch. When a pitcher winds up and pulls the baseball way back, he's loading up a massive amount of potential energy. In the exact fraction of a second his arm whips forward and the ball leaves his hand, that potential transforms instantly into roaring kinetic energy as the ball flies toward home plate. But at the exact same time, the biological work done by his muscles during that throw is breaking down chemical energy from whatever he ate for lunch, which releases thermal energy, making him break a sweat. So you've got potential, kinetic, chemical, and thermal energy all happening in one simultaneous, flawless display of physics. So we've gone from defining energy to watching it dynamically transform under the unbreakable law of conservation. Let's see how much you've picked up. Can you answer these? What is potential energy? What's kinetic energy? And can you name 3 specific forms of energy? Think about it for a second. And while you do, consider this wild fact. The chemical energy fueling your body right now originally came from the sun, which itself was formed from the kinetic and thermal energy of the Big Bang. You are quite literally powered by the ancient energy of the cosmos. It's just passing through you in different forms. So, as you go about your day, what will you transform that energy into next? Keep observing those invisible forces powering your world. Stay curious, and I'll catch you on the next explainer.